This lecture is on data collection and use. It is in Module 1, Data Science. Why do we collect data? Typically, we have a problem to solve, an issue to address, or a topic to explore. We call this problem, issue, or topic the research question. The research question guides our study. We collect data from our sample to try to answer our research question, which targets our entire population. When we collect data, we have two options. We can take a census, or we can take a sample. A census measures the entire population. A sample measures a subset of the population. One of the most famous examples of a census is the U.S. Census, which occurs every 10 years. In the U.S. Census, the entire population is asked specific questions that are of interest. However, the census is costly in terms of time and money, and it can be difficult to reach everyone in a large population. For example, in the 2010 census, I wasn't included. My parents were told that I would fill out a form at my university, while officials at my school told me my parents would fill out my information. This can happen to more than one person in a large population. It is time-consuming to create a concise survey to send to the entire population and to accurately compile that information once it is received. It is costly to send the surveys, have them returned, and pay people to compile the information. Oftentimes, workers are hired to collect information from people who do not return the census forms. This is an additional cost that must be accounted for when looking at a census. Therefore, many choose to use a sample. If the sample is selected correctly, it will give an accurate picture of the population. Therefore, to select a sample, we need to define the population and plan a strategy for finding the best picture of the population. When selecting a sample, we want to avoid biased samples. These are samples that systematically miss a portion of the population. Two examples are voluntary response and convenience samples. Voluntary response samples include those who choose to respond or to be in the study. This may exclude people who did not see the recruitment flyer or do not have a strong opinion about the topic or issue. A convenience sample is one in which subjects are selected because they are easily accessible to the researcher. Again, certain people may be missed by the researcher, thus not giving an accurate representation of the population. A random sample is a sample that allows random chance to select subjects from the population and is considered the gold standard for sampling. In a random sample, subjects in a population are listed in what is called a sampling frame. A random number table or generator, such as computer software, is then used to select the sample from that sampling frame. Keep in mind, however, that taking a random sample is not always possible. There are different types of random samples. 3 of these include simple random samples, stratified random samples, and cluster samples. First, an example of a simple random sample would be if I wanted to select a random sample of University of Kentucky students. Each UK student has his or her own student ID, which would make up the sampling frame. I could use a random number generator to randomly choose a certain number, say 100, of those IDs. Second, an example of a stratified random sample would be if I wanted a sample of the U.S. population. I could divide the United States into 4 regions: North, South, Midwest, and West. These regions are known as strata. I could then take a random sample of individuals in each region. Third, an example of a cluster sample often arises with mailings. There are 39 zip codes in Lexington, and I want to send a mailing to some Lexington residents. Instead of taking a random sample of all Lexington residents, I could take a random sample of 5 zip codes from the 39 possible and send the mailing to everyone in those 5 zip codes. Stratified random sampling and cluster sampling are similar in that they divide the sampling frame into groups. However, in stratified random sampling, a random sample is selected from each strata, while in cluster sampling, a random sample of the groups is selected, and everyone in the selected groups receives the survey. Remember that a variable is what is measured on a subject. There are different types of variables, some of which give more or less information than others. In this course, we will be dealing mainly with continuous variables. Continuous variables contain an unlimited range of possible values, though sometimes the possible values are constrained. For example, height is a continuous variable, but height must always be greater than 0. Categorical variables have a limited range of possible values, or categories. Ordinal variables have a natural ordering to them. For example, shirt sizes, small, medium, large, etc., are ordinal. Nominal variables do not have order. If I were to ask everyone their favorite fruit, there are only so many fruits that can be named, and they do not have a natural order to them. Dichotomous variables have two options, yes or no. This yes or no may take different forms, but it essentially boils down to one of the two responses. Count and time are special variables that may be considered continuous or categorical depending on the situation in which they are used. Later in this course, we will see an example of when a count variable is considered continuous, but otherwise just know that count and time are special.